Hey everyone, ready for another deep dive? You sent us this paper called Auto-Encoding Variational Bayes, and wow, it's got some seriously cool stuff about how AI learns. I'm so excited to break it all down with our expert today, so, we can all really get what's going on here.
It's a pretty fascinating paper for sure. It gets right to the heart of how AI is changing, how it's taking on these harder and harder problems.
Yeah, like you might be thinking, okay, I kind of get how AI learns already, but this paper, this AEVB thing, it's like that's the secret behind some of the most impressive AI stuff out there. It's all about those situations where the important info, it's hidden. Almost like, trying to solve a puzzle, but like half the pieces are gone.
That is a great way to put it, that missing piece problem. That's something traditional AI really struggles with,
Hmm.
especially with like tons and tons of data. But AEVB, it's got this clever way of getting around that by, well, combining a few key ideas. Honestly, the first time I saw it, it kind of blew me away.
Okay, so now I gotta know, what are these mind-blowing ideas?
So one of the big ones is this thing called variational inference. Um, you can think of it like this. You're trying to figure out the shape of something, but you can only see its shadow. Like, you can't see the actual object. But you can still make some pretty good guesses just based on the shadow. How big it is, the shape, the way it changes when you move things around.
So it's kind of like the AI is playing detective, right? Using clues to figure out what's hidden.
Exactly. And that's where the recognition model comes in, or what we usually call the encoder. Like a detective, right,
Yeah.
checking out all the evidence, looking for anything that might tell us about what's hidden. And guess what? In AEVB, this detective is often a neural network. Those super powerful AI systems designed to learn patterns.
Right, right. So this neural network is going through all the data, trying to pull out those hidden clues. But then how does it go from those clues to actually like recreating the information, like what it's supposed to be learning?
Okay, so that's where the generative model comes in, or the decoder. So imagine now, like an artist who has to recreate a scene, but all they have are a detective's notes, right? They have those clues, the colors, the shapes, where things were,
Yeah.
and they try to piece it all together. And just like the encoder neural networks, those are often what we use as decoders in AEVB.
Okay, I'm following. So we have these two neural networks working together. One is finding the clues, and then the other is using those clues to like rebuild the original information. They're like a dynamic AI duo. But where does the whole variational thing come in?
That's a great question. It's all because of this thing called the variational bound. See, in AEVB, we're not actually looking for a perfect reconstruction, like an exact match. Instead, we use this bound to kind of measure how close the reconstruction is to the original, like finding the best fit rather than trying to get everything exactly right.
So it's more about minimizing the difference, not being totally perfect. Makes sense, especially when you have all this complex data to deal with. But how does the whole AVB process actually work, like step by step?
Okay, so picture the data, right? It flows into the encoder, which then tries to pull out those hidden clues, those what we call latent variables. Then the decoder uses those variables to try and rebuild the original data. And this whole process, it repeats itself over and over. Each time, both the encoder and the decoder, they learn from their mistakes, so they get better at their jobs.
Like they're practicing, right? Getting sharper with each try. But with all this complexity, how do we actually use AEVB? Like in the real world, it still sounds kind of theoretical.
So that's where the reparameterization trick comes in.
Yeah.
It's this technique that makes AEVB, well, it makes it work with all the standard tools we use to train AI.
Yeah.
It's like, translating between two different languages so everything can run smoothly.
Okay, I'm intrigued, but also maybe a little intimidated. Can you unpack that a little? What does this trick actually do, and why is it so important?
So it's all about making AEVB easier to train and get better at its job. You see, AEVB uses probabilities, randomness, to handle those hidden variables. But a lot of the ways we train AI, they don't really like randomness. So this reparameterization trick, it's like a clever workaround. Instead of having the AI wrestle directly with randomness, we give it a set of controls it can use to influence the random stuff.
So we're giving AI more control over the randomness, so it's easier to kind of steer towards the answer.
Exactly. And you know what? It's this trick that lets us build something called a variational autoencoder. And that's a really powerful type of AI where both the encoder and the decoder, they're neural networks.
Variational autoencoder. Okay, sounds like we're leveling up the AI wizardry here. What makes them so special, so powerful?
Well, we know neural networks are amazing at handling complex data, right? And variational autoencoders, they use two of them, one for encoding and one for decoding. That combo makes them super versatile, ready to tackle all sorts of problems.
So it's like this awesome team of neural networks working together to figure out hidden information. Wow. It's amazing how all these pieces fit together. But what makes AEVB so special in the grand scheme of AI? Like, why should we care about this one technique so much?
What's really cool is how AEVB brings together these two ideas in AI that you wouldn't think go together. Probabilistic models, which are all about uncertainty, and then autoencoders, which are all about, like, learning these efficient ways to represent data.
Okay, connecting the dots, I like it, but can you give me a little more context here? What do these ideas actually bring to the table, and why is their fusion such a big deal?
Okay, so probabilistic models. Those let us represent data in a way that, like, acknowledges we don't know everything for sure. It's like
Right.
saying, we don't know exactly what's going on, but here are the most likely scenarios. Autoencoders, on the other hand, they're like master data compressors, taking tons of data and squeezing out the most important stuff, creating this little package that's way easier to work with.
So AAVB is like combining the best of both worlds.
Yeah. Exactly. It uses probabilistic models to handle all the uncertainty of those hidden variables and then leverages the awesomeness of autoencoders to be super efficient. And since we're often using neural networks for both encoding and decoding, we get this amazing power to deal with really, really complex data. This connection is a big deal because it's really changed what AI can achieve.
It's like AVB opened up this whole new door in the world of AI, all these new possibilities. I'm seeing why you were so excited about this paper, but let's get real here. What can AEVB actually do? Real world examples, please.
Oh, there are so many. AEVB is like the Swiss Army knife of AI. It's used for everything from making realistic images to cleaning up noisy data to learning these super powerful ways to represent data. It's wild how this idea that seemed so abstract is having a real impact on the world.
Okay, wait, hold on. You've totally got my attention. How does AEVB make realistic images, like AI creating art? That just sounds crazy.
So imagine you train an AEVB on like huge data set of images, maybe tons of pictures of cats. The encoder, it learns to identify those hidden features, those key things that make a cat, well, a cat. And then the decoder, our AI artist, it uses those features to generate brand new images of cats that look incredibly real, like unlike anything you've seen before.
So it's not just copying existing images and mixing them up, it's actually creating something new based on what it's learned. That's incredible.
Yeah, it really is. And this ability to generate new data, it's not limited to just images. AEVB can work with other types of data that have complex structures, like text or audio.
Okay, mind officially blown.
Yeah.
But you know me, gotta know how this awesome tech is actually being used out there. What are some real examples of AEVB making images?
Oh, there are tons. One really cool area is drug discovery. Researchers are using AEVB to create images of new molecules that have specific properties, and those could lead to new drugs.
Wait, so AEVB can help design new drugs? That's incredible. It sounds like something out of science fiction.
I know, right? It's totally changing the game for the pharmaceutical industry. By training AEVB on all these existing molecules and what they do, it can learn to create images of molecules that might have those special effects they're looking for, like maybe to target a specific disease.
Like it's an AI chemist that can dream up new molecules. That's insane.
Are there other examples in medicine?
Oh, for sure. AEVB is being used to make medical images too, things like x-rays or CT scans. And those can be so valuable for training. Imagine like a medical student learning to read x-rays. Instead of just using real patient data, which can be limited, they can use AVB to create thousands of fake x-ray images to practice with.
That's so smart. That's like having an AI that can make a whole library of medical images, giving those students so much more to learn from.
Yeah. And it's not just for training. These fake images, we can also use them to test and improve those algorithms that doctors use to make diagnoses. So diagnoses get more accurate and faster. Wow, so AEVB is making art, cleaning up messes, and even helping us discover new drugs. Okay, I'm convinced this tech is going to revolutionize healthcare. But what about other areas? Any like surprising or unexpected uses of AEVB you've seen?
One that I find really cool is how it's being used in fashion. Imagine an AI that can create clothing designs or accessories based on what you like,
Hmm.
or even like a virtual fashion show with AI-generated outfits.
Whoa, that's wild. AEVB could be the next big thing in fashion then. I can totally see that happening. Like having your own AI stylist who knows your taste perfectly.
Definitely something to keep an eye on. AEVB, it's so good at learning patterns and making new data. It just seems perfect for the creative world of fashion.
This is all so incredibly exciting, but now I'm curious about what's going on behind the scenes. Are there new things happening with AEVB that researchers are working on? Like what's next for this technology?
Oh, there's always something new in AI. One exciting area is, well, making those AEVB models more efficient and robust. so they can handle even more complex data. Remember that variational bound we talked about? The one that measures how close the reconstruction is to the original.
Right, right. It's like the scorecard for how well AEVB is doing its job.
Exactly. Researchers are always looking for better ways to estimate and tweak that bound, to make those AEVB models even more powerful and accurate. They're finding new ways to refine those algorithms and make them work better.
So, like, they're fine-tuning the engine to make it run even smoother.
Yeah, that's a great way to think about it. And another cool area is, trying out new designs for those encoder and decoder networks. The neural networks, remember, are AI detective and artist.
Yeah, those are the ones doing all the hard work in AEVB.
For sure. Traditionally, we've used pretty simple neural networks for these tasks, but researchers are trying out more fancy ones now. Things like convolutional neural networks, which are especially good for image data.
So, like, giving our AI detective and artist better tools so they can be even more skilled.
Exactly. These improvements are giving us AEVB models that can pick up on even the tiniest details and the more complicated relationships within data. It's really pushing the limits of what's possible with this technique. It's a really exciting time to be following all the research.
I'm with you there. This deep dive has been like a whirlwind of information. We started with the basics of AEB, and now we're talking about all these real-world applications and the cutting-edge research that's shaping its future.
It's amazing to see how far AEVB has come and the potential it has. It's a real testament to just how clever and creative the researchers in AI are.
I totally agree. But something's been on my mind this whole time. With all this talk about AI learning and creating and even making art, it makes me wonder, is there a connection between AEVB and how our brains work?
That's a really fascinating question. And you know what? It's something researchers are starting to look into. It's still early days, but there are some interesting similarities popping up between AEVB and how our brains process information.
Okay, now that is something I want to hear more about. Tell me more.
Well, think about it. Our brains are constantly getting all this information from the world, and somehow we make sense of it all. We filter out the noise, we find patterns, we take all that chaos and turn it into something meaningful.
Right, so it's like our brains are doing their own encoding and decoding, just like AEVB.
Exactly. And some researchers think that this might actually involve something similar to encoding and decoding, just like AEVB. Maybe our brains are taking sensory information and turning it into these compact representations, those latent variables, and then decoding those to create how we see and understand the world. It's still pretty speculative, but it's a really cool area to research.
So you're saying those latent variables, those could be like the building blocks of how we think and perceive things. It's like AEVB is giving us a new way to study our own minds.
It really is. Of course, our brains are infinitely more complex than any AI we've made. But exploring these connections can give us some really cool insights into both the power of AI and, its limitations.
This is blowing my mind. It feels like we've just started a whole new chapter in our deep dive. But I think we should save this fascinating brain AEVB talk for part 3, where we can really get into the bigger questions, like what does this all mean and how could this technology help us understand our own minds even better?
Welcome back to our AEVB deep dive.
All right.
One of the things that makes this algorithm so powerful is its ability to learn from complex data, especially when dealing with those hidden, latent variables.
Right, like those latent variables hold the key to like unlocking the secrets within the data. But I'm curious, are there certain types of data where AEVB really shines, like where it just, blows other approaches out of the water?
Absolutely. You'll find AEVB it's really good in situations where the data has this really complex structure that's hard to model directly. And a prime example of that, image data.
Images, yeah, that makes sense. They're full of like details and patterns and all sorts of things.
Exactly. Think about all the little variations in just one image. The colors, the textures, the shapes, how all the objects relate to each other. It's a lot for an AI to process, right?
Hmm.
But AEVB, because it can learn those hidden representations, the ones that capture those intricate patterns, it's been super successful in tasks like, well, image generation and image denoising.
Okay, let's zoom in on that image generation thing for a sec. This is the part that really captured my imagination.
Yeah.
How does AEVB actually create those new images? It almost sounds like magic.
Okay, imagine this. You train an AEVB model on a massive data set of images, let's say pictures of faces. The encoder, what it does is it learns to pull out those latent variables, those essential features that represent what makes a face a face. It's like it's learning the blueprint.
So it's figuring out the ingredients of a face, but instead of using flour and sugar, it's using these latent variables, right?
That's a great way to think about it. So once the encoder has that blueprint, that, recipe for a face, the decoder steps in. Remember, the decoder is like our AI artist.
Right. So the decoder takes those latent variables, that blueprint, and it tries to generate a new image that matches those characteristics.
Exactly. And the amazing thing is, the decoder can even combine and tweak those latent variables to create like totally new and unique images that still, look like faces.
So it's not just copying and pasting existing faces. It's like it understands the underlying structure of a face and then uses that to create something new. That's incredible.
It really is. And this ability to make new data, it's not just for images. AEVB can be applied to other types of data that have those complex structures, things like text or audio.
Okay, my mind is officially blown. But you know me, I always got to know how this amazing tech is actually being used. Are there any real examples out there of AEVB being used to make images?
Oh, tons. One area that's super exciting is drug discovery. Researchers are using AEVB to generate images of new molecules. And these molecules have specific properties that could, like, lead to new drugs.
Hold on, AEVB can help design new drugs. Now that's incredible. It's like science fiction becoming reality.
It really is pretty amazing. It's a game changer for the pharmaceutical industry.
Yeah.
Think about it. By training AEVB on data sets of all these existing molecules and what they do, it can learn to generate those images of molecules that might have like therapeutic effects they're looking for, like
Yeah.
targeting a specific disease.
It's like having an AI chemist that can imagine new molecular structures. That's incredible. Any
Right.
other examples in medicine?
Absolutely. AEVB is also being used to generate medical images, things like X-rays or CT scans, which are super valuable for training purposes. Imagine like a medical student who needs to learn how to interpret X-rays. Instead of just relying on real patient data, which can be hard to come by, they can use AEVB to generate like thousands of synthetic X-ray images to practice with.
That's brilliant. It's like having an AI that can create a whole library of medical images so those students have way more to learn from.
Exactly. And it's not just about training either, those synthetic images.
Mhm.
We can also use those to test and improve the algorithms doctors use for diagnoses. So, diagnoses become more accurate and faster.
Okay, so we've got AEVB creating art, cleaning up messes, and even helping us discover new drugs. This is clearly a technology that's going to revolutionize healthcare. What about other fields, though? Any surprising or unexpected applications you've come across?
One area that I find really interesting is how AEVB is being used in fashion. So imagine an AI that can generate designs for clothes or accessories, all based on your personal preferences. Or even picture a virtual fashion show with models wearing outfits created by AI.
That's wild. So AEVB could be the next big thing in fashion design. I can definitely see that happening. It's like having a personal AI stylist who knows your style perfectly.
Yeah. It's definitely an area to watch.
Mm.
AEVB's ability to learn complex patterns and create new data, it just seems perfect for the creative world of fashion.
This is all so incredibly exciting, but I'm also curious about what's happening behind the scenes? What are the new things researchers are exploring with AEB? What's on the horizon for this tech?
Oh, there are always new frontiers in AI. One exciting area is, well, developing more efficient and robust AEVB models that can handle, even more complex data. Remember that variational bound we talked about? That measure of how close the reconstruction is to the original?
Right, right. Like the scorecard for how well the AEVB is doing.
Exactly. So researchers are always working on improving how we estimate and optimize that bound so they can make those AEVB models even more powerful and accurate. They're finding, new ways to refine the algorithms and make them work even better.
So it's like fine-tuning the engine to make it run smoother and faster.
That's a great way to put it. And another cool area is, well, exploring new architectures for the encoder and decoder networks. Remember, those are the neural networks that are, our detective and artist.
Right. They're the ones doing all the heavy lifting in AEVB.
Exactly. Traditionally, we've used, relatively simple neural networks for these tasks, but researchers are experimenting with more sophisticated ones now, things like convolutional neural networks. Those are especially good for image data.
So it's like upgrading the tools of our AI detective and artist to make them even more skilled.
Precisely. These advancements, they're leading to AEVB models that can capture even more detail, even the really fine details and those more complex relationships in the data. It's really pushing the limits of what we can do with this technique. It's an exciting time to be, following all the research.
Totally agree. This deep dive has been a whirlwind. We started with the basics of AEVB, and now we're talking about all these incredible real-world applications and the cutting-edge research that's like shaping its future.
It's amazing to see how far AEVB has come and, all the potential it has. It really shows how smart and creative the researchers in AI are.
Couldn't agree more. But there's this one thing that's been on my mind throughout our conversation. With all this talk about, AI learning and generating data and even making art, it makes me wonder, is there some kind of connection between AEVB and how our own brains work?
That is a fascinating question. And you know what? It's something that researchers are, starting to look into. It's still early days, but there are these interesting parallels popping up between AEVB and how our brains, handle information.
Okay, now that's something I definitely want to hear more about. Tell me more.
Well, think about it this way. Our brains are constantly getting bombarded with all this sensory information, right, from the world around us. And somehow we manage to make sense of it all. We filter out the noise, we find patterns, and we take all that chaos and we turn it into, something meaningful.
Right, it's like our brains are doing their own version of encoding and decoding, just like AEVB.
Exactly. And some researchers, they believe that this process might actually involve something like encoding and decoding, just like we see in AVB. Maybe our brains are taking all that sensory input and encoding it into these, compact representations, like those latent variables we've been talking about. And then they decode those representations to form, how we perceive and understand the world. It's still a pretty speculative area, but it's a really fascinating avenue for research.
So you're saying that those latent variables, they could be like the building blocks of our thoughts and how we see things. It's like AEVB is giving us this whole new way to look at and study our own minds.
It really is. Of course, our brains are way more complex than any AI system we've ever created, right? But exploring these analogies, it can give us some really valuable insights into both the power and the limitations of AI.
This is mind-blowing. It feels like we've just opened up this whole new chapter in our deep dive. But you know what? I think we should save this fascinating brain AEVB discussion for part 3. Then we can really delve into those bigger philosophical questions like what does this all mean? And how could this technology help us understand our own minds, even better?
Welcome back. I don't know about you, but after that last part, I'm still kind of wrapping my head around this idea that, AEVB could be like a mirror for how our brains work. It's amazing how digging into this one algorithm has taken us to, these really big questions.
It really is, just shows how AI isn't just about solving those everyday problems. It can maybe even help us understand ourselves better.
So let's jump back into that question then. Is there a real connection between AEVB and the human brain? Could this algorithm be giving us, a peek behind the curtain of how our minds work? Well, like we said before, it's still, early days in this research.
Yeah.
But those parallels we talked about, how our brains are constantly filtering and processing information, that's got some scientists wondering if there's something deeper going on.
You mentioned that some researchers think our brains might be using a process similar to encoding and decoding. Can you break that down a little more? What does that actually look like in the brain?
Okay, so imagine you're watching a sunset,
Yeah.
all those amazing colors and shapes, right? Your eyes are taking it all in. So what if your brain, kind of like the encoder in AEVB, is grabbing those key elements of that scene, like the colors, the clouds, maybe even the feeling of the warmth on your skin. And it creates this compact version, like a mental snapshot of the whole experience.
So it's like our brains are making those latent variables, those little packets of information to represent this whole complex sensory experience.
Exactly. And then later on, when you're trying to remember that sunset, your brain, acting like the decoder now, rebuilds the experience from those latent variables. It
Yeah.
brings back all those sights and feelings and even, those emotions you felt at that moment.
That's amazing. Our brains are running their own version of AEVB, right? Encoding experiences into those latent variables and then decoding them to make those memories come alive again. Is there specific brain research happening that's looking into this connection?
One area is visual perception. Researchers are using models that are kind of like AEVB to study how our brains recognize things,
Hmm.
objects and scenes. And the really cool thing is these models, they're starting to create representations that look a lot like what we see in the visual cortex.
Hmm.
That's the part of the brain that handles visual information.
Whoa, so we're building AI that's starting to see the world kind of like we do? That's pretty exciting, but also a little, I don't know, weird to think about.
I get it. It makes you realize just how powerful these AI tools are becoming. And another area where researchers are exploring this connection is memory and learning. AEVB, remember, it's really good at learning from data and making new stuff. So it could help us understand how our brains form memories, how we learn new things and how we take what we know and apply it to new situations.
It's like AEVB is giving us this whole new way of thinking about how our brains learn and adapt. This is incredible.
It really is. But it's important to remember that all this research is, well, it's still pretty new. This connection between AEVB and the brain, it's mostly uncharted territory. But it's a frontier with a lot of potential.
It feels like we're on the verge of this huge scientific shift where AI and neuroscience are coming together to figure out how the human mind really
Yeah,
works.
totally agree. It's such an exciting time to be working in these fields.
Well, as we wrap up our deep dive into AEVB, I want to thank you so much for taking us on this incredible journey. We started with, the nuts and bolts of this algorithm, and now we're talking about the big picture, the philosophical stuff, and how AI could help us unlock the mysteries of our own minds. Amazing.
The pleasure was all mine. It's been a really great conversation.
And to you, dear listener, we hope this deep dive has sparked your curiosity and maybe given you a new appreciation for the incredible power of AI, not just to change our world, but to help us understand our place in it. So keep exploring, keep asking those big questions. Who knows what other amazing things you'll discover out there?